Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Dutch Flatmates Ziffers by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that every row, column, and designated 9-cell region, which is a box, must contain the digits 1 through 9 once each. Every 5 in the grid has a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. So this is Dutch flatmates. So for example, if this were a 5, it has to have a 1 above it or 9 below it. Or it could have both, but it doesn't need both. And that's an example of how Dutch flatmates work. And every 5 in the grid has this constraint. Also, any pair of cells that are an equal distance from the central spot of a colored ziffer line have a difference equal to the digit on that central spot. So, for example, this could be something like 7 and 3. And then this would have to be 4. Because the difference between 7 and 3 is specifically 4. And so the difference between, again, digits that are the same distance from the central spot of a colored ziffer line has a difference equal to the digit on that central spot. Or you could have something like 7 and 3 there, and this could be 4, and that would be valid for at least this portion, because 7 and 3 has a difference of 4, which is they are 2 away from. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. I am not very experienced with ziffer lines. I think I've done like maybe 1 or 2 puzzles with it, so I don't really know any intuitions about it. I actually don't even know how it relates to like a full set of the digits 1 through 9. Obviously, 9 can never be in the middle because the difference of 9 digits would only be 1 and it could be 1 and 10 or 0 and 9, but those are not normal Sudoku digits. 8 can only work for 1 and 9. 7 can only work for 1, 8, and 2, 9. Anything from 3 through 6 fails. 6 can only work for 1, 7, 2, 8, and 3, 9. 5 can work for 1, 6, 2, 8, 3, 9. Sorry, 1, 6, 2, 8, 2, 7, 3, 8, or 4, 9. So the difference could be 1 through 5 here. So this could be 1 through 5. And that's for... So that's for a full set. And that's the same here, right? These are 1 away from each other. These are 2 away. These are 3 away. These are 4 away. And it's a whole box worth, which is the digits 1 through 9. So again, 6 and above does not work. 6 requires 1, 7, 2, 8, and 3, 9, and does not work for 4 and 5. So this is 1 through 5. This could be 1 through 6. It cannot be 7 because that can only work for 1, 8, and 2, 9. And 3 through 6 are out of luck. But this could be 6 here. What does that mean? I don't really know. This can't... No, this could be 5 if this is 9. So these are the ones opposite. These are the ones opposite. These are the ones opposite, and these are the ones opposite. Every 5 in the grid has a 1 directly above it or 9 directly below it. So this 5 here has to have, in this line, has to have a 1 directly above it. You cannot have a 9 directly below it. But we don't really know what that means. I'm going to pause. I need to go to the bathroom right now. I'll be right back. And I'm back. Okay, let's continue. One thing I thought of while I was going to the bathroom was that 4 doesn't really work either. If you have 4 digits, where can the 8 be, essentially? The 8 has to be next to can only be next to 4 on this Ziffer line if the difference is 4. But then obviously we have a 4 already in the same row or the same box there. So therefore 4 cannot work. This could be 4 if 4 is outside, right? So this doesn't have an 8. 5 still works again. 5 breaks them down into 4, 9, 3, 8, 2, 7, and 1, 6 as the pairs. 4 does not work. 3, I think, does. 6 and 9 could be next to each other. So 9 has to be next to 6. 8 has to be next to 5. Oh, no, it doesn't work. So 5... 9 has to be opposite 6. 8 has to be opposite 5. 7 has to be opposite 4. 6 has to be opposite 3. But then 2 and 1 don't have a pair. So it cannot be 3. Because then 5 can only go to 2 or 8. But the problem is that, yeah, you have a difference there. I don't think you can have 2 either. If you had a 2, that means 6 can only go to 4 and 8, but the other 4 and 8 doesn't have another 2 to have a difference of. And then you have all the odd digits, which only 4 of them can be in sets, and then the last one is left out. So this cannot be 2. This can't be 2. This becomes a 1-5 pair here. And the 5 has to either have a 1 above it or a 9 below it. Well, if this is 5, it can't have a 1 above it because that would be 1. If this is 1, obviously could be. So this has to be 1. This is 5. The 9 has to be below it. This cannot be 1 or 5. So a difference of 5 means you have to have 4 and 9 together. So this is 4 and 9. You have 3 and 8, 2, 7, and 1, 6. And we're not sure which any of those are. This can't be 4. So 1 and 6 have to be opposite each other. Because these two must have a difference of 5. And these two must have a difference of 5. And the only one left out is 6 now. So this is 6. Which means the difference must be between 1 and 7, 2, 8, and 3, 9. So this becomes 1, 2, 3, 7, 8, 9. This becomes 1, 2, 3, 7, 8, 9. That leaves this as 2, 3, 7, 8, 2, 3, 7, 8. We don't know which. The difference of 1 works. 2 is with 3, 4 is with 5. 5, 6 is with 7, 7, 8 is with 9. The remainders here are 1, 2, 3, 7, 8, 6, 7, 8. That means we have a 4, 5 pair in row 1. So this is 4, 5. One of them has to have a 9. So if this is 5, this is 9 below it, because it can't have a 1 above it. So there's no difference of 9 between 5 and another digit. So this must be 5 here. So this must be 5 and 9. That makes this a 4. This 5 eliminates 5 here, so that's 4. None of these can be 9. So since these can't be 9, the corresponding 3 cannot be there. 5, 4, and 9. Because the difference between 5 and 9 is 4. So this 5 is done. This 5 is satisfied. Because it has a 9 below it, 9 below it. 5 cannot be here. It couldn't be here anyways, but yeah. 5 is one of these two. 5 cannot be here because, well, no, 1 could be above it, technically. 9, where's... Okay. These have to be differences of, again, we're not sure. 1 cannot be here, so, well, 6 can't be here. 4 cannot be here, so 9 cannot be either of these to be corresponding to here. Right, so what digits can this be? Again, 1, 2, 3, 4, 6, 7, 8, 9. This cannot be 4 or 9. And this can't be 6. So 1 would be with 6 here, so that's possible. 2 would be with 7. 3 would be with 8. 7 would be with 2. 8 would be with 3. So those are the possibilities. Okay. Where is the 5 in this box? 5 can not be here or here. Because if 5 is either of these, it doesn't have a 1 possible to be above it. So 5 has to be either here or here. If this is 5, this is guaranteed to be 9. If this is 5, this has to be guaranteed to be 1. Either way, 5 cannot be here on this difference of 1. 2 has to be with 3. 4 has to be with 5. 6, so 5 has to be with 4. So this can never have a 4 here. Where is the 4 then in this box? It has to be here. So this is guaranteed to be a 4-5 pair because there's no other place for it. Right? The 4 has to be with 9 along this ziffer line of 5. Which means, where's the 9 in this box? It must be one of these two cells, and 9 must be specifically with 8. So that eliminates 8 and 9 in the rest of the box. So this cannot be 8, which means this cannot be 3. Because 3 can only be opposite the ziffer with 8. And since this can't be 8, this can't be 3. We have a 1, 2, 7, 8 quadruplet in box 2, which eliminates 1, 2, 7, 8 in the rest of the box. So this becomes a 3, 9 pair, which is a difference of 6 away. So this cannot be 9, this cannot be 3. That leaves the remaining digits as 4 and 5. Well, this 5 cannot, well, okay, it's guaranteed to have a 1 above it. This 5 can have a 9 below it. This 5 could have a 1 above it. What's the difference between these, I guess? Remaining digits in row 9 are 2 through 7. So this can't be 4, so that means this can't be 5. This can't be 4, so that means this can't be 5. One of these is 6, so one of these is a 1. Remaining digits in row 2. Could be 2, 3, 5, 6, 7, 8. This 2, 3 cannot be 5, could be 6, 7, 8. Okay, this can never have a difference of 8 between 4 and 5. No 8's possible, no 7's possible, no 6 is possible. So this is 2 or 3. Same here. This can't be 5. It could be 5 here. So 6, 7, or 8 is possible here. That means where is the 6? The 6 has to be one of these two digits. And you cannot have a difference of 6 between 4 and another digit. So 6 has to be here. That makes this 6. This is 2. This 2 eliminates 2 here, so it's 3. This can't be 2 or 3, therefore this is 5. So this must be 4 and 5, adding up to 9. Difference of 9 and 4 is 5. Difference of 6 and 4 is 2. So this cannot be 2 here. That forces this to be a 1, 7, 8 triplet, which eliminates 1, 7, and 8 in the rest of the box. So this is 2. This difference must be 5 between this cell and this cell. So this is 7. So this cannot be 7 here. This can't be 7. This can't be 7. This can't be 2 because of the 2 in the column. So this is 3 and 8 have a difference of 5. That eliminates 8 here and 8 here. Eliminates 3 here and 3 here. 5 has to have a 1 above it or a 9 below it. Cannot have a 9 below it, so must have a 1 above it. So this cannot be 1 or 2. 1 has a difference of 6 with only 7, so this is 7, which makes this 8 and makes this 2. This has a difference of 3, this is 5. So this 5 cannot have a 9 below it, so it must have a 1 above it. So this must be 1, this is 7. That 1 corresponds to this digit, so that's 6. This 7 corresponds to this digit, so it's 2. This can't be 5, this is 4, this must have a difference of 2, so that's 2. This 4 eliminates 4 here, so it's 5, then 9 has to be below it, so that's 9, this is 8. Remaining, this 9 eliminates 9 here, so it's 3 and 9. Remaining digits in column 4. We do not have 6 or 7 or 3. And remaining digits, this can't be 1, 2, or 8. Okay, 2 cannot be any of these digits, which means the corresponding 3, which has to be 1 apart from it, cannot be here. This can't be 3, so therefore this can't be 2 here. So 3 could be here or here. 3 away from 5 is either 2 or 8, and 2 is already in the box, so this must be 8. Okay. This can't be 7. So again, the corresponding 6 cannot be here. This can't be 5, so the corresponding 4 can't be there. This can't be 2, so the corresponding 3 can't be there, whereas 2 and 3 in row 9. It has to be here. So this is 2, this is 3. Okay. Remaining digits in box 1 are 3 and 7. Remaining digits in box 3 are 1 and 6. Okay. Remaining digits in row 7. We have 1, 3, 5, 8, and 9. Okay. This cannot be 5 or 9 or 3. If it's a difference of 8, it has to be between 1 and 9. So this cannot be a difference of 8. It has to be 1. This can't be 1 or 3. This can't be 1. This can't be 8 or 9. This can't be 5 because of the 5 in the column. This is a difference of 1. So there could be 2, 3, 3, 4. Except that, okay, so 2 and 3 cannot be here because 2 and 3 just can't be here. 3 and 4 works if this is 3 and that's 4. We can't have a 5 in the column. 6 and 7 work. 7 and 8 work. So those are the possibilities. This 1 eliminates 1 here, so that's 6, which makes this 1. Okay, so this can't be 6. That means the corresponding 7 cannot be there. So again, this can't be 6. Again, this could be 3, 4, or 7, 8 here as differences. You can't have 5 and 6. This can't be 2 or 3. And we can't have a 9. So that means in the rest of the column, you can't have 4 or 7 because one of these is 4 or 7. So that means one of these is 4 or 7. So this is 2, 3, or 8, with 2 guaranteed to be one of these two. Okay, remaining 5 and 9. This cannot be 5 because we can't have a 1 above it, and you need to have a 1 above it. So this must be 6, which makes this 7 to be next to it. This has to be 4 and 5 with a 1 above it. That eliminates 5 here, so it's 3. This can't be 3 or 5. This can't be 3, therefore this must be 5 here. You could have the 1 above it, you could have the 9 below it. This cannot be 3 and 4, therefore it's a 7, 8 pair, which forces this to be a 2, 3 pair here. This has to be 7, 8, and 9 here. That forces this to be a 4, 6 pair. 6 cannot be here because of 6 in the column. So this is 4, that's 6. The 5 has a 1 above it, so that's satisfied. This 5 has a 9 below it, so that's satisfied. This 5 has a 1 above it, so that's satisfied. This 5 has a 1 above it, so that's satisfied. This 5 needs to have a 1 above it because it can't have a 9 below it because of the 9 here. So 5 cannot be here, so 5 has to be here, and it has to have a 1 above it. So this is 1. This leaves this as a 7. So this cannot be 1 here, this can't be 7. 7 corresponds with 2, 1 corresponds with 6. These digits, 2 and 3 is possible. Only if this is 3 and that's 2. 3 and 4 is possible if this is 3 and that's 4. We can't have 4, 5. Can't have 5, 6. No 6, 7. No 7, 8. Could be 8, 9 as long as this is 8 and that's 9. Okay. This 7 eliminates 7 here. This 8 eliminates 8 here. Remaining digits in column. So we have to have a 5. So this is a 5. Where's the last remaining 5? In row 4, it has to be here. And we have a 1 above it, so that's satisfied. So again, 5 has a 1 above it, 5, 1 above it, 5, 9 below it, 5, 1 above it, 5, 1 above it, 5, 9 below it, 5, 1 above, 5, 9 below, and this 5 we don't know yet. Okay. So this is either 2, 8 or 3, sorry, 2, 7 or 3, 8 here. So one of these digits is 2 or 3. One of these digits is 2 or 3. That eliminates 2 and 3 in the rest of the row. So the rest of the row cannot be 1, 2, 3, or 5. So it's 4, 6, 7, 8, 9. Well, let's see what we can eliminate. This can't be 4 or 7 because of the 4 in the column, the 7 in the box. This cannot be 7 or 6 because 6, 7. Oh, this 7 eliminates 7 here. So this is 3 and 7 here. Okay, that is not helpful. That's fine. This cannot be 6 or 7 because of the 6, 7 in the column. This can't be 4, 8 because of 4, 8 in the column. Okay. Okay. Remaining digits in column 7. We have 4, 8, and 9, and one of these is guaranteed to be 4. Remaining digits in column 8. We have 1, 6, 7, and 9. And this cannot be 9. This cannot be 9. Oh, it could be 9 if that's 1. That's fine. Either this is 1, 6, 2. Oh, this can't be 7, so this can't be 2 and 7. So this is 1, 6, or 3 and 8. Okay. Um, hmm. Hmm. Okay, remaining digits in column 1, 3, 6, 8, 9. This cannot be 9 because of the 9 in the row. Remaining digits in column 3. 2, 4, 8, 9. No 4 here. Hmm. Oh, this becomes a 1. Yeah, this... Why can't that be 2? I don't know. Oh, I messed up. These are opposite each other. That's the reason why I was there. Okay. So the 2 is there still. So this could be 1, 6, 7, 9. Oh, this can't be 9 because of 9 in the row. 3, 6, 8. 2, 8, 9. Okay, so this is opposite that, right? Hmm. This is still the same. So these... No, we don't have anything that interacts that way. Um, hmm. Okay. If this is 3, this becomes 9. That makes this an 8 to have a difference of 1 between them. But this 3 has to be 5 away from 8 here, so this can never be 3. Right? So again, if this is 3, this becomes 9 and 8, but this has to be 3 and 8, and therefore we have a contradiction. So this cannot be 3. This must be 6, which is opposite 1. So this cannot be 1 here. This can't be 6 here. Where is the 2? We have 2 guaranteed to be in rows 4 and 5 in box 5. We have 2 guaranteed to be in rows 4 and 5 in box 6. That eliminates 2 from the rest of the rows 4 and 5. Where's 2 in box 4? It has to be here. So 2 must be here, which makes this 3 to have a difference of 1. 3 eliminates 3 here, so it's 2 and 3. 2 eliminates 2 here, so it's 8. That makes this 2. This must be a difference of 2 and 7. Sorry, 7 and 2 subtracting together, you have a difference of 5. That forces this to be 3. This cannot be 3. This 7 eliminates 7 here. This can't be 1. No, it can't be 6 or 7. This 8 eliminates 8 here, so it's 9. Which eliminates 9 here, so it's 1. 9 eliminates 9 here, so it's 8 and 9. This can't be 8 or 9, so it's 4. That eliminates 9 here. This 4 eliminates 4 here. So this must be 4 here. This 1 eliminates 1 here, so this 5 has to have a 9 below it to satisfy the Dutch flatmates. So this is 9, that makes this 6, which makes this 7, which makes that 8, 7. This 9 eliminates 9 here, so it's 8 and 9. That eliminates, this 6 eliminates 6 here, so it's 8, and that's a 6. Huh, interesting. Very, very interesting, actually. The zipper lines is very different from the zipper lines that I think they sort of originated from. It's more restrictive in some senses, but also less restrictive in some senses, too. Huh. Fascinating. Yeah, I think like zipper lines, you can't ever have a 9 on the non-central part of a zipper line, right? That's where zipper lines are really restrictive versus ziffer lines. But zipper lines can only have certain values in the middle if it takes up all of a box or all of a row. So that's where ziffer lines are more restrictive. Huh. Or are they? I mean, still have to have a 9 in the middle, I guess. Maybe they aren't. Maybe it's just, yeah, maybe it's just happenstance. Anyways, I hope you enjoyed today's solve, and I'll see you next time on Frank Puzzles. Take care.